Good evening, students.
Good evening, ma'am.
Good evening.
Yeah, all of you should write your attendance, your name and enrollment number in the chat box. Today, if some people new have joined, please write your name and enrollment number in the chat box for attendance. Right. So yesterday we had done we had done history of computers, and we were studying fundamental of computers. So we'll be doing that. And we were doing classification of computer yesterday. So we have seen analog and digital computer, right?
Yes, ma'am.
You can see my screen is shareable now.
Yes, ma'am.
Yes, ma'am.
So yesterday we have seen regarding our analog and digital computer. Now that is one type of difference or classification. Now the other type of classification is size and memory. So according to size and memory, your computers are classified as supercomputers, mainframe computers, mini computers, workstations, microcomputers, or personal computers. Right. So supercomputers are the fastest. They have lot of memory, and their size is also big. That means they have more size, biggest size, and they have the fastest memory, and they are generally used for scientific applications and all that, right? For weather forecasting, for atomic research or whatever. So supercomputers are the one which are the largest computer with more space and more faster. Then at second place comes mainframe computers. So mainframe computers are those computers which are server computers, or you can say in businesses or government organizations, mainframe computers are being used for keeping records of data and all that, like in banking or other things. So you have server or a machine which is a high-end machine which can handle number of users. So those machines are known as mainframe computers. They take less space than supercomputers, but they are bigger machines, and they are less faster than supercomputers. They are faster but less faster than supercomputers, right? So supercomputers are the fastest and have lot of memory. After that, mainframe computers come, which are server computers generally, and then comes mini computers. Mini computers are your laptops, or this basically mobiles are also there, right? So those kinds of things are your mini computer. They will have less mini computers or personal computers. You can say personal computers or microcomputers are your desktop, right? Which will have less memory and less space. It will take less space. Laptops and your desktops are personal computers or microcomputers. So, and workstations are also the same. If you talk about workstations are also the same. You can say any desktop machine can be a workstation also. So if we talk about microcomputer and workstation, they are the same. Earlier, microcomputer or personal computers had less space. Now you have your hard disk space, and your speed is getting increased, but they are not faster than mainframe and supercomputers. They are less faster and less memory than supercomputers. And the size now, your laptop size is 14.1 or 15 point something inch is there, and same way your desktop has different monitor size and all that. It is also decreasing a little, and mini computers are the one which have already, your mobile is a mini computer, your tablets. So these kinds of things are mini computer which have less which takes less space. They can come in your hand, and the memory size is not according to the laptop or your desktop, but a little less, and the speed is also okay, not much like a laptop or desktop, but speed is okay. So that kind of differentiation, size and memory, your computers have been divided. So this is a supercomputer, right? So supercomputers are the most powerful computers. They are used for problem requiring complex calculations. Because of their size and expense, supercomputers are relatively rare. So supercomputers are used by universities, government agencies, and large businesses also, right? So if I talk about India's first supercomputer, anybody knows which is India's first supercomputer? India has made. What?
Aryabhat.
Not Aryabhat. The first supercomputer which India made was Param. PARAM by CDAC. Right. Same way in world also, I think Cray supercomputer was the one which was created the first in the world. That was supercomputers, right? They were used for specific applications like weather forecasting, atomic research, nuclear research, and all that. So they are used by government agencies also, universities also, and large businesses also. This is mainframe computers. You can see a room inside there. The server is there. So mainframe computers can support hundreds or thousands of users. Basically, they have to handle number of users like in banking or in colleges or something like that. So handling massive amounts of input, output, and storage, mainframe computers are used in large organizations where many users need access to shared data and programs. And mainframes are also used as e-commerce servers handling transactions over the internet. So basically, if you talk about Amazon and all that, so they will be taking help of supercomputers also, but generally they are mainframe computers. Right. Then come mini computers are smaller than mainframe but larger than microcomputer. Mini computers usually have multiple terminals. Mini computers may be used as network servers and internet servers. So basically, they are also servers, but they are less than mainframes, and they can be used as server for where multiple users can access the server or network servers or internet servers. So you can use mini computer also. And then workstation is a normal desktop single user computer, right? And are used for tasks that require a great deal of number crunching power, such as product design and computer animation. So workstations are often used in network and internet servers also. So you can use mini computer also, you can use workstation also. Right now your systems are designed in a way that a single system has so much of power that it can handle this animation and all those things, and it can also do many things like a server. So that thing is also there. Then microcomputer or your PC are most commonly known as personal computer. Is a compatible computer. Full-size desktops are the most common type of PC. Notebook, laptops are computers are used by people who need the power of a desktop, but also portability. So that is what is there. And later on, your handheld devices have also come. That is your tablets and mobiles are also there. So that those are also there. That you can say are handheld PCs, where you can handle it with your hand, right? So, and one more thing was there. One more classification was there according to purpose. If we talk about according to purpose, we have two kinds of classification: general purpose and specific purpose. So general purpose means for any kind of work we can use, like we are using a desktop or a laptop or whatever machine is there, we are using it for general purpose, right? Special purpose means those people who are using it for special things, like they are doing it for animation, or they are doing it for research work or some nuclear energy, something. So special things if they are doing, so that is known as special purpose computers. And for general purpose, we all are using it for general purpose, so those are general purpose. So this way your computer classification is being done. So you have according to technology, you have according to size and memory, and you have according to purpose, right? Any doubts in this?
Okay.
No, ma'am.
Yes,
Right? Okay, fine. So now we had to go, I had yesterday also told you that we had to go to binary number system, right? So whatever your data is represented in computers, computer can understand one language, and that is known as what? Binary.
binary
Right?
language.
Right. So binary, bi means in Roman, bi means two. Right. So by
Yes,
there
ma'am.
are only
Zeros and
two.
ones.
Yeah, there are only two numbers in binary. That is why the base is 2 of binary, and it is known as 0 and 1. Right. So I am just minimizing this, and we'll do this number system first. Right. So according to the number system, we have 4 kinds of number system. Right. Decimal number system. What is decimal number system? The number system we study in our normal maths. In mathematics, we study this number system, right or wrong?
Yes, ma'am.
Our numbers are from 0 to 9.
Yes, ma'am.
Right. So this is our number system which we generally study in our mathematics. So the base of this is, because deca or deci means 10. Right. So from that came decimal number system, and decimal's base is 10. If you count from 0 to 9, how many numbers are there?
10.
10.
9.
Right?
10 numbers. 10.
So decimal number system has base 10. Then comes binary number system. Binary number system, there are only two numbers, 0 and 1. So base is 2. Right? Which we talked about, which the computer understands. This is the computer which can understand. This is our number system which we understand. Right? Then comes octal number system. Octal. Oct means 8. Right? So octal number system will have base 8, and there are numbers from 0 to 7. Right? There are no numbers of 8 and 9. Like in decimal, you have up to 9. There are only numbers. There is no 8 and 9 in octal number system. There is only 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. So 0 to 7, the total comes out to be 8.
8.
Right?
Yes.
Then comes hexadecimal number system.
Hexadecimal.
Hexa means 6. Decimal means 10. Right? So 10 plus 6, how much is the base?
16.
Right. So hexadecimal number system has base 16, and there are numbers from 0 to 15. Right. If you count 0 to 15, it will come out to be 16. But here, what happens is, we will talk about it later. Here, up to 0 to 9, it is decimal normal 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But after 9, it is alphabets. We will not write 10, 11, 12, 13, 14, 15. It will be A, B, C, D, E, F. Right? There will be alphabets in hexadecimal. So we'll talk about that. So you should know these number systems. You have decimal, you have binary, you have octal, you have hexadecimal.
Ma'am, where these third and fourth are used? Suppose decimal numbers are used in mathematics, etc., or binary number system are used in computers.
And computers also, nowadays computers are also using hexadecimal number system also.
Yes, ma'am.
They are also using hexadecimal number system. Octal number system is also used, but less, but hexadecimal is used more. So these are
But
also
ma'am,
being used.
But ma'am, how is it possible? As you said yesterday.
They convert it from binary. They convert hexadecimal or decimal. Depends.
Yes, ma'am.
Your answer may be given in hexadecimal, may be given in binary, may be given in decimal. Can be.
Okay.
That means output
So they
will be
are
in this
using it for naming purposes. They are also using hexadecimal number system also.
Ma'am, that means when the output will came, they came in the form of octal number system or
Yeah, it can
number.
come. It can output will come in binary only, but it will give it to you in hexadecimal if you want the answers to be in hexadecimal or octal.
Okay, ma'am.
It will give the computer will calculate everything in binary only.
Yes.
But it converts to decimal or octal or hexadecimal according to your wish, if you want. But these are also the number system, which can
we, ma'am, can we say that binary number system is a basic number system of the computer, and these options are output systems, they are
generally for the output. If you want that your answer should be in hexadecimal, decimal, or whatever, then the computer can convert it and give it to you in that format. So they are also there.
Yes, ma'am. Thanks. Yes.
Right. So for one thing, I just wanted to suppose I have a number in decimal number 895 base 10. Base 10 means this is a decimal number system, right? Right. So how I represent this number in a decimal number system? So what we do normally in maths is we see the place value, right? Here it is hundreds position. This is ones position. This is this is 10th position. This is ones position, right?
Yes.
So other thing is what you do is you see there are three numbers, right? 1, 2, 3. 8 and 8, 9 and 5, right? 3 numbers,
Okay. Yes.
right? So what we do is we take 10 power 1 less 10's power, right? So what we do is 8 into 10 to the power 2. 3 numbers are there, we are taking 1 less power, right? So 8 into 10 to the power 2 plus the next number is 9. 9 into 10 to the power 1. Go on decreasing the power now. 2, 1 and plus next number is 5 into 10 to the power 0. Do you understand?
Yes, ma'am.
Right.
Yes,
So
ma'am.
what is 10 to the power 0? I told you yesterday anything to the power 0 is 1. So what will be 5 into 1 will be 5.
Yes, ma'am.
Then
That is
10 to the
5.
power 1 will be 10. So 9 into 10 is 90.
Yes.
Right? And 10 to the power 2 is 100. So 8 into 100 is 800.
800.
So add it, what number will come?
895.
Right. So this is the way you represent a number, how the number has come. Right. I'm just giving you an example in
Okay.
decimal. This is what we do. Right. So now our first thing will be how to convert a decimal number to binary.
Binary system.
So what is the formula is that you divide the number by the base. So base is 2 of binary. Yes or no?
Yes.
So you have to divide the number by 2 and you have to keep on writing the remainder of that number. The remainder will always come out to be 0 or 1. If you divide a number by 2, the remainder will always come out to be 0 or 1. Do you understand? So this is the formula for converting a decimal number to binary. So everybody who is a person who cannot understand my English or cannot understand the words, either they know in Hindi what to do. Everybody is able to understand now what is division, what is remainder.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So 127 is the number, that is the decimal number, and I want to convert it into a binary number, right? So I will divide this, keep on dividing this number until 1 or 0 comes. Right? Until when you have to keep on dividing this number? Until 1 and 0 are coming. So you divide 2 6 are 12, 2 3s are 6. How much is the remainder?
1.
1. Right? 2 3s are 6, 2 1s are 2. What is the remainder?
1.
1. 2 1s are 2, 1 1 is left, 2 5s are 10.
Yes.
How much is
10
the
and
remainder?
1.
1. Then 2 7s are 14. How much is the remainder?
1.
1. 2 3s are 6. How much is the remainder?
1.
1. And 2 1s are 2. What is the remainder?
1.
1. So all the things you have divided the number unto 1. 1 tak aapne divide kar diya hai, right? Now how
Yes.
you read this number is from down to above. Do you understand?
Yes.
So your number will be 1 1 1 1 1 1 1. From
7.
down to above.
That is 7.
You have to write.
If we
Your first
add
one
from
is here. Right? This is your first one, then second, then
1,
third,
2,
fourth,
3,
fifth,
4,
sixth,
5,
seventh.
6, 7. Okay.
Right?
Then
Understand?
3, 7, then, ma'am, how can we second number we can add? How we will add it?
Edit means what?
Because you told that 1, 1, 1, and 1. That means we have added from below to high.
Yeah,
1, 2,
I've
3,
written
4,
this
5.
now.
Yes.
7 numbers here. Yeah.
Yes. Means it comes 7.
Yeah,
And how
7
it comes
ones.
2 and 1?
It
Yes.
can
How
come
it
8
comes?
also, it can come 6 also, but this 127 is giving you 7 ones, right?
Okay.
Right. Now suppose you have a number called 1975 decimal number. Now convert
Yes.
this number to binary. So 2 9s are 18, 1 7, 2 8s are 16, 1 5, 2 7s are 14, remainder is 1. Okay? And again divide 2 4s are 8, 1 9, 1 8, 2 9s are 18, 2 3s are 6, remainder is 1. Okay? Then 2 2s are 4, 2 4s are 8, 1 3, 2 6 are 12, remainder is 1. Then 2 1s are 2, 2 2s are 4, 2 3s are 6, remainder is 0. 0 can
Zero.
also come. Do you understand now?
Yes. Yes.
Yes,
Only
ma'am.
ones will not come, 0 can also come. Then 2
Yes,
6 are 12 and 2 1s are 2. What is the remainder? 1. Then 2 6 are 2 3s are 6, and can 1 be divided with 2?
No.
No. So what will we do? 2 zeros are 0. Remainder will
Remainder
be
will be 1.
1.
1. Then 2 1s are 2, 1 0, 2 5s are 10, remainder is 0. Right? 2 7s are 14, remainder is 1, 2 3s are 6, remainder is 1, 2 1s are 2, remainder is 1. Understand?
Yes,
Yes.
ma'am.
Now read it from down to above. So it is 1 1 1 1 0 1 1 0 1 1. This is our
That is binary.
Ma'am,
3 times 1.
will you please? Hello.
Yes.
Ma'am, will you please give this from 123 where 0 comes?
123 is 2 6 are 12, 2 1s are 2, remainder is 1, right? Yes or no?
Yes.
Then 2
Yes,
3s
ma'am.
are 6, 2 and 1 cannot be divided, 2 3s are 6 is 0, then 1 cannot be divided by 2, so 2 zeros are 0, remainder will be 1. Now can you understand?
Yes, ma'am.
Yes, ma'am.
And 2 7 2 1s are 2, 1 0, 2 5s are 10 and 0, remainder is 0. So now you can divide ahead also, right?
Ma'am, if the question is in points like 1,
I am not understanding, your voice is breaking.
hello.
Huh.
Ma'am, if the question is in points like
That will be
127.8,
that is decimal point numbers, I understand. We'll do it ahead. It will be coming ahead. Don't worry. Right?
okay, ma'am.
Right now, just see the simple conversions, because you must be knowing certain things, or some people must be knowing the conversions, but most of the people will not be knowing the conversions. So we have to start from the base only. You'll be doing the decimal number conversions also.
Okay, ma'am.
Right? Now,
Ma'am,
all of you are what?
can we get notes for this?
I'll forward it to you. If you have made all of you have made a group of WhatsApp now.
Yes,
ma'am.
I have a group.
Yes, ma'am.
So what I'll do is you can give me the link and I will add myself in that.
Yes, 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 ma'am.
Okay,
I'll
ma'am.
forward this.
Ma'am, I have pasted the
Yes,
link in
ma'am.
the
That
chat.
will be a great help.
Okay, I'll do that. So right now we'll just finish the class, then we'll discuss later on,
Okay,
right?
the link is in the
Okay, ma'am.
chat, ma'am.
Yeah, I'll copy that. So decimal, everybody is able to understand how to convert a decimal number to binary?
Yes,
Yes, ma'am. Yes, ma'am.
Right, so
Yes, ma'am.
computer can understand this, these numbers, 111, 1101, these numbers computer can understand. So this is conversion from decimal to binary. Now, from binary to decimal, how would you convert? If you are given a binary number,
Okay. Yes.
right? You are given a binary
Binary
number.
number.
I have taken the same number to verify. I have taken the same number, 127's binary. This number I have taken,
1, 1.
right?
Yes.
The same number I have taken, the 7 1 I have taken. This is my binary. Base 2 is there. That means it is a binary number, and I have to convert it into what?
Decimal number.
Decimal. So how would I convert it into decimal? So count the number of digits. Count how many digits were there? 7 now? 7 ones were there. Take
Yes.
you have to multiply by the base, but power of the base, but power should be 1 less than the number of digits. So first digit is 1 into 2 to the power 6.
6.
2
Plus
into 6.
next digit is 1 into 2 to the
Plus
power 5.
1,
Keep on
2 into
decreasing.
5. Yes.
Plus 1, next number is also 1
2
into 2 to
into
the power
4.
4. Plus next number is 1 into 2 to the power 3. Plus
2 into
next number is
3.
1 into 2 to the power
2
2.
into 2.
Plus 1 into 2 to the power 1. Plus last is 1 into 2 to the power 0.
2, 3.
All the numbers have been covered, right?
Yes.
Okay.
So 6, 5, 4, 3, 2, 1, 0. So this way you will write. Now, I have yesterday I have told you now what is 2 to the power 0, 1, 2 to the power 2, 2 to the power 3, 4, right? We have discussed yesterday.
Yes, ma'am.
Yes, so 2 to the power 6 is 64. Right? I have this table also I have on side I have created. 2 to the power 6 is 64. So 1 into 64 is 64 only, right?
Yes.
Yes.
Plus 2 to the power 5 is 32. 2 to the power 4 is 16. 2 to the power 3 is 8. 2 to the power 2 is 4. 2 to the power 1 is 2. And 2 to the power 0 will be 1. So 1 into 1 is 1. Right?
Yes, ma'am.
And add all the numbers, you will get the same number, 127 base 10, which we have converted. So our number is also verified that our answer is correct. Can you understand?
Yes, ma'am.
This is how you convert a binary number to decimal. Any doubts anybody is having?
No, ma'am.
Understand, ma'am.
All of you are able to understand how to convert it, both,
Yes. Yes.
right?
Yes,
So
ma'am.
I have taken
Yeah.
any number.
Ma'am, actually, hello.
Yes.
Actually, I have a doubt
Ma'am.
where we can find the recording of this session. Actually, something is missed by me, so I can go to
Something
that
is missed
particular
by you
recording.
means what?
Yeah, in the previous session.
In the yesterday's session.
Yes, I have missed.
Actually, they will upload it on the website. Yesterday's session must have been recorded, so it will be uploaded later on. You don't worry, it will be uploaded in the time to come.
Thank you
On
so
the
much.
LMS portal you will find, or they will release YouTube videos also.
All right. Thank you so
Right.
much.
Thank you, ma'am.
Ma'am, will you
Right.
please
So
take one more example?
what we were doing is another example. I just dumbly took one number. Suppose my number is 110111. Any number I have took, a binary number, right?
Yes.
Now, how many digits are there in this number? You have 6 digits,
Yes. 6.
right? So I'll take one power less to convert it into decimal. So 1 into 2 to the power 5 plus 1 into 2 to the power 4. The third digit is 0. So plus 0 into 2 to the power 3. Then again 1 has come, plus 1 into 2 to the power 2 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. Right?
Yes, ma'am.
Right?
Yes, ma'am.
Now just put your calculations. 2 to the power 5 is 32, 2 to the power 4 is 16. This will come out to be 0. Even if it is 2 to the power 3 is 8. 8 into 0 will be 0 now.
Yes.
Right? Then 4, then 2, then 1.
That's
Right?
55.
It's 55 if you add. So this is how you convert a binary to decimal. You can also take this number. You can also take this 1975 also and try to convert it back to decimal. You get the same 1975, you can check. Right?
Okay,
You can check yourself.
Yes, ma'am.
So everybody is able to understand both the things, how to convert a binary to decimal and decimal to binary.
Yes,
Yes.
ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. Now we go to the second number system which we talked about was octal, right? Octal number system. Octal number system base is
8.
8 and numbers are from
basis.
0 to
7.
7.
0 to
1, 2,
7.
3, 4, 5, 6, 7. Can you see that?
Yes.
Yes,
Yeah.
sir.
So if we talk about in binary, how to convert an octal number to binary, if we talk, we'll make a table. 8 in binary is represented, 2 to the power 3 is 8.
Yes.
Yes.
Yes, ma'am.
So how
Yes,
many
ma'am.
digits we require to represent a binary number in matlab, an octal number in binary? 3 digits we require in binary.
Okay. So the
Right.
power specifies how much digit it will
Yes, the power specifies how much digits we need to represent a octal number in binary.
be. Okay.
Right. So if it is 0, it will be 3 times zeros. In 3 bits we have to represent. So 0, 0, 0. Right? And
Okay,
when
ma'am.
it is 1, it is 0, 0, 1. right? When it is 2, it is, if you divide 2, this see 1 cannot be divided by 2, 0 cannot be divided by 2. Binary, you have to divide everything by 2, yes or no?
Yes,
To
ma'am.
convert anything into binary, you have to divide it by 2, yes or no?
Yes, ma'am.
Yes,
Yes,
yes.
ma'am.
Yes.
ma'am.
So 0 and 1 cannot be divided by 2, no?
No.
Yes.
So it will be 0, 0, 0 and 1 will be 0, 0, 1. In 3 bits, 1 will be there and ahead will be 0, 0. Do you understand? But 2 can be divided by 2, right?
Yes.
So if we divide 2 by 2, what will be the remainder? 2 ones are
1, 1,
remainder is
0.
0.
What is the answer? 1, 0.
1, 0.
Yes?
Yes.
Yes,
1, 0. So I have written 1, 0 and the third, because I have to represent it in 3 bits, ahead I have put another 0. So it is in 3 bits, 0, 1, 0. Can you understand?
Yes.
Yes, ma'am.
Same way, if you divide 3 with 2, 2 ones are 2, remainder is 1. Yes?
Yes.
Yes.
So
Yes,
1,
ma'am.
1, 1 is the answer, right?
Yes.
So it for 3 bits I have to represent, so 0, 1, 1 I have written. Can you understand that?
Yes,
Yes,
ma'am.
ma'am.
Same way, 4 if you divide, it will come out to be 100. 5 you divide 101. 6 you divide 110. 7 you divide 111.
Actually, we are not
They
getting
will
it.
be
Can
3
you
bits
please
only.
repeat this second?
What are you not getting?
Like, how come all 3 digits will be divided into? I'm not getting it.
All
Part.
3 digits will be divided means?
Like,
See,
how did you
first
do
I
that
told you
calculation?
0 and 1 cannot be divided by 2.
Yes.
Yes or no? Right. So
Yes.
you will represent 0 as 3 in 3 bits 000, and you will represent 1 in 3 bits as 001. Yes?
Okay.
Right? If you divide 1 by 2, so 2 zeros are 0, remainder will be 1, so 01 will be the answer.
Okay.
Right? So ahead I have put one more 0 to represent it in 3 bits. Same way, if you divide 2 with 2, it will give you 1 0. 2 ones are 2, remainder is 0, 1 0 will be the answer. And to make it a 3-bit number, I have put ahead 0, 0 1 0.
Okay.
And same way, if you divide 3 with 2, so 2 ones are 2, remainder is 1. 1 1 is the answer. To make it a 3-bit, it will be 0 1 1. Right?
Yes.
Say, if you divide 4 with 2, it will give you a 3-bit number only, 100. If you divide 5 with 2, it will give you 101. If you divide 6 with 2, it will give you 110. If you divide 7 with 2, it will give you 111.
Okay. Now understood. Thank you.
Right? But every time you will not remember, because I am teaching, so I remember all the digits, what it gives. But you'll not remember every time you keep on dividing, it will be cumbersome for you. Keep on dividing which number comes, which is the number 10 is coming, 101 is coming, 110 is coming. So how to remember this table is, if you see the first column, it is 4 times 0, 4 times 1. Right?
Yes, ma'am.
Second column is 00, 11, 00, 11. And last column, that is your third column, is 01, 01, 01, 01. Now can you write the table?
Yes, ma'am.
Yes.
If your numbers are 0, 1, 2, 3, 4, 5, 6, 7, your octal numbers are these. So how will you create the table? First column 4 times 0, 4 times 1. Second column 2 times 0, 2 times 1, 2 times 0, 2 times 1. Third column 0, 1, 0, 1, 0, 1, 0, 1.
Yes.
Yes.
So your table will
Ma'am,
be made.
Ma'am, in this digital this 4, when we divide 4 into 2, that means that comes to, and how it is
100.
Yes.
Yeah. It will be a 3-bit number only, na?
Yes,
we
ma'am.
write remainders. We write remainders, right? Don't
We
consider
write
2. We write
remainders.
remainders.
We write remainders, and that also from down to above.
Ma'am, when we divide 4 into 2, that means 2 2s are 4, remainder is 0.
0. Yes.
Yes, but I have written it 1.
I have written it 1.
Yes,
Who
1
has
0 0.
written?
That means, ma'am, you have written it 1 1 0
I
0
have
means
not
1.
written 1 1.
It is in the
You have
reverse
to
order.
read
It is
it
a
from
reverse.
down to above. Your
So
0
first one
is
0.
here, then the other 0 is here, then 1 is here. So down to above. 1 0 0 like that you have to read.
Okay. Okay, ma'am.
Just wait, I'll just show you on the whiteboard. Has the whiteboard opened? See, if I divide 4 with 2, your number will be 2 2s are 4, remainder is
0.
0, right?
Then we divide
Then
again it by 2.
2 1s are 2, and remainder
0.
is 0. So
0.
until this you have to divide, you have to read it like this,
Okay, ma'am, I got it. Okay, ma'am, thank you. Thank you.
right? I
Yes.
already told you it is read from
1,
down to
it
above,
is down to above. Okay, ma'am.
right?
Okay, okay.
That's why I have written it is 100. Same way 5 will be 101, 6 will be 110, 7 will be 111. But for you will not keep on dividing always to do it fast. So just remember this table: 4 times zeros, 4 times 1 first column, 2 times 0, 2 times 1, 2 times 0, 2 times 1 second column, 0 1 0 1 0 1 0 1 third column. Right?
Ma'am, I have one doubt.
What?
I have one doubt.
Yeah.
In when we write number 2 in octal number, it is 010.
Hmm.
Okay, and remainder is 10.
Yes,
Again, when we divide,
because ahead we have to add another bit to make it a 3-bit number.
yeah, that I know. What I want to ask is when we divide 4, the remainder
It
is
is
same
already a
as
3-bit. It is already a 3-bit number, na? Why would I add another 0 or something?
okay.
It is already a 3-bit number. 5 is already a 3-bit number. 6 is already a 3-bit number. 7 is already a 3-bit number. Why would I add anything then?
Okay, so from 4 we don't have to add anything.
No, 4, 5, 6, 7 we don't have to add because they were not the 1, 2, 3 are not 3 bits. They are 2 bits. So we have added zeros ahead. Right?
Okay, ma'am.
We
Thank
have
you.
to
Thank you.
represent each number in octal in binary as a 3-bit. 3-bit should be there.
Yes, ma'am.
So now can you understand the table
Yes.
of
Yes.
decimal system? Right. Now you convert octal number to binary. Suppose there is a number called 105 in octal. See, there is no 8 and 9 here. Right. So this is an octal number. Right, numbers should be from 0 to 7, then only it is an octal number. So 105 is an octal number, okay?
Yes.
Now, how would you
Yes.
represent this number in octal? You first see 1. You in your table 1 is 001.
Yes.
You write 001 in place of 1. Then 0 is 000. You write 000. Then 5 is 101. You write 101. See from the table, right?
So we are basically using the table to derive the
to derive the octal to binary.
Okay.
Simple. But the leading zeros, see there are leading zeros here. Can you see that? 0
Yes.
0?
Yes.
These leading zeros are not generally in some entrance exam or in some question papers. Some question comes at 105 is ABCD option and the answer is this from here. So that doesn't mean your answer is wrong. You don't count the leading zeros. That's why you don't write it and you write the answer from 100 101. Do you understand?
Okay.
So you can see from here your
Excuse me, ma'am.
answer, you can match the answer.
Excuse me, ma'am.
Manji,
Ma'am, can you please explain it again because my internet was fluctuating. I cannot understand it.
see, there is this you understood now, octal to binary,
Yes, ma'am, I have understood that one, but I
the
have
table
not understood
also,
that. What, ma'am?
the table you have understood, right?
Yes, ma'am, yes.
Okay. Now suppose you have a number called 105. This is an octal number, basis 8, that means octal number. The octal number will not have number 8 and 9, it will only have numbers from 0 to 7. Right? So 105 is an octal number. Now if you want to convert it into binary, just simply see the numbers. First is 1. So what is 1 in your table? Equivalent binary 001. So write 001. Right? Then 0, what is in your table equivalent binary is 000. Right? So write 000. Then see 5 is in your table equivalent is 101, write 101. It is converted.
Okay,
Right?
ma'am.
Now
Okay.
can you understand?
Yes, ma'am.
Yes, ma'am.
Yeah. Now why I am saying is that these ahead zeros, the leading zeros are not counted or not written in answers. Only from here 100, 101 will be written. That means your answer is not wrong. The leading zeros are not written generally. That's why. But your answer is correct. You can match it from here, up from here.
Okay, ma'am.
Right? Then, now suppose a number is 157. This is also an octal number. There is no 8 and 9 here also. So 157 is an octal number. Now convert this number into binary. 1 is 001. 5 is 101. 7 is 111 from the
Yes.
table. Yes?
Yes, sir.
Yes, ma'am.
Again, ahead the leading zeros, leave it. Your answer is 110, 1111. Right?
Okay, ma'am.
Yes.
Any doubts in this? Convert octal to binary.
No.
No,
No,
ma'am.
ma'am.
Right. Then when we convert a binary to octal now, suppose a number is given 100, don't see this leading zeros, number is from 1000101. Suppose this is your number. Right? So how will I convert this 1000101 number to an octal number? So what I'll do is from the rightmost bit, that means from the end, you will divide your number in 3 bits. Because octal number has 3 bits, you have to represent a number in 3 bits, yes or no?
Yes, ma'am.
Yes, ma'am.
Yes. So from the last bit, that is your rightmost bit, from the last, just start dividing in 3 bits. So 101 is the first 3 bit, then 000 is the next 3 bit, and 1 is left. Don't see this 1 is left. Now what will happen to the 1? I will add 00 ahead of it to make it 3 bits. Do you understand?
Yes, ma'am.
So ahead I have added 2 zeros, so I have made it 001. So this is my 3 bits, next 3 bits. So my number is 001 is 1, 000 is 0, and 101 is 5.
Fine.
See, I have taken this number only. See this number only. 1000101. This number only. Can you see that?
Yes.
Yes,
And
ma'am.
from the last bit, from the rightmost bit, I have divided it into 3 bits. And the last one will be left. So make it a 3 bit. I add 2 leading zeros ahead and just see what numbers are coming from the table. So this is 105. Right? Same way I have taken
Yes.
another example, 1101 1111. Right? Don't think this leading zeros, just ignore it. First, see your number is 1101 1111. This is your number. Now you have to convert it into octal. This binary number has to be converted into octal. From the last, that is your rightmost bit, start dividing into 3. So 111 is divided, then 011 is divided, and 11 is left. 2 numbers are left. To make it a 3 bit, I have added 0, so 011. Can you understand?
Yes, ma'am. Yes, ma'am.
Yeah, so it has become 337.
Understand.
337.
Yes, ma'am.
Right? Any doubt?
No.
No, ma'am.
So
No,
now
ma'am.
binary, octal to binary and binary to octal also understood?
Yes.
Just you have to
Yes,
remember
ma'am.
this table.
Yes, ma'am.
This table is important.
I have one question, ma'am.
Yeah.
This is the simple chart from 0 to 7 used in
Hmm.
octal system. Can this system be adopted in decimal system from decimal
No,
to binary?
no. Decimal cannot be adopted like this.
Okay, okay. What can you tell me the reason when I can't
See,
get
the decimal number system, each bit is taken individually.
uh, okay,
Each bit is taken individually. There is no definite bit that your answer will come in decimal to binary. Your answer will come in 3 bits or 4 bits or something. There is no definite bit.
okay,
Each
okay.
bit is taken separately. That's why you always have to divide it by 2
Yes, yes,
in
yes.
decimal. But in
Okay.
octal, because its base is 8 and 2 to the power 3 is your there. One more thing is there. 10 cannot be represented in 2 to the power. Decimals base is 10 now,
Yes.
and 10 cannot be represented in 2 to the power. Can 10
Oh,
be
yes.
represented
Right,
in 2 to the
right,
power? No.
right,
No,
right,
ma'am.
right, right. Yes, ma'am.
So that's why you cannot implement that how many bits will be required for a decimal number system.
Exactly, exactly. Right, right, ma'am. I got it, ma'am.
So for here you can represent, because 8 is there is 8 2 to the power 3 8 is there, so in 3 bits you can represent that, right? So both the conversions are understood.
Yes, ma'am.
Yes,
Can we
ma'am.
move ahead now?
Yes, ma'am.
So
Yes,
now
ma'am.
comes your hexadecimal number system, right? Now hexadecimal has base how much? 16.
16.
Hexa plus decimal
16.
6 plus 10, right? So 16 is
Yes.
represented in binary as 2 to the power 4.
Yes, ma'am. Yes, ma'am.
So 4 bits will be required to represent a hexadecimal number in binary, right?
Okay. Okay.
So from 0 to 15 your numbers are there, hexadecimal.
Yes.
So 0 to 15, I told you already that in hexadecimal 0 to 9, the decimal number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 will be the same. But 10, 11, 12, 13, 14, 15 will not be 10, 11, 12, 13, 14, 15. They will be alphabets A, B, C, D, E, F.
Yes, ma'am.
Right? Because we cannot represent a 2-bit number like in hexadecimal, 2-bit numbers are not written, two-digit numbers. So they are represented as A, B, C, D, E, F alphabets. Right? After 9. Understood?
Yes, ma'am.
So now to represent hexadecimal, 0 will be 4 times zeros, 1 will be 001, 0001, and 2 will be again 10 is the answer. I'll add it 2 zeros ahead, so 0010. 3 is 11, so 00111. Now 4 was in binary was 100. I add 0 ahead, so 0100. And 101 is 5, so I'll add 0 ahead, so 0101. 6 is 110, so I'll add 0 ahead. So this kind of a thing has come, right? You keep on dividing, divide also this number, so this thing comes. But to remember that, again I am telling you, from if in hexadecimal there will be 8 zeros and 8 ones in first column. How many zeros? 8 zeros
And 8
8 ones.
ones.
8, 1.
And in the second column 4041 4041.
Yes, ma'am.
And the third column 00, 2 times 0, 2 times 1, 2 times 0, 2 times 1, 2 times 0, 2 times 1, like this. And in the last column it will be 0101010101.
Okay.
Yes, ma'am.
Your table will be made, right?
Okay.
In octal it was 4 times zeros, 4 times 1, and 0011 and 0101. In this 8 times zeros, 8 times 1, then 4 times 0, 4 times 1, then 2 times 0, 2 times 1, then 010101. right?
Understand, ma'am.
So now, if you want to convert a hexadecimal number to binary, suppose you have a number called AB5. Is it an hexadecimal number?
Yes.
Yes,
ma'am.
because you have alphabets A and B and you have 5 also, so AB5. It is an hexadecimal number. Now to convert this number into binary, A, you see the equivalent digit, it is 1010. B is 1011 and 5 is 0101, right? From the table.
Yes.
And simply it is converted. Right?
Okay.
Any
Yes,
problems?
No, ma'am.
No, ma'am.
Right. If you want to convert a hexadecimal number to octal, what will you do? Suppose your question says that you have to convert a hexadecimal number to octal or octal number to hexadecimal. What will you do? Can
Multiply by
anybody
8.
tell? No. If you want to convert a hexadecimal number to octal,
We will
convert
first
that,
convert into
first
binary.
convert it into binary and
Binary and
from
then
the last
binary to
one,
octal.
last digits, just divide it into 3 bits. So it will be converted into what?
Binary
Octal.
and then binary to octal.
Octal.
So hexadecimal converted it into binary, binary converted into octal. In 3 bits start dividing from the last bit. So this is 5, this is 6, this is 2, this is 5. 52658 octal. Simple or not?
Yes, ma'am.
Yes. If suppose octal number is given and you have to convert it into hexadecimal, then convert the octal number into binary, divide in 4 bits from the back, and that will be your hexadecimal.
Yes.
Right. So when you are converting binary to hexadecimal, suppose this is your number 101011. This is your number. Don't think this leading zeros, just remove it. First it is 101011. Right. Now I have to convert it into hexadecimal. So what will I do? In 4 bits I have to divide from the last. Right. So this is 0111 and this is 101. Now I have to have 4 digits, so I have added 0, so it is 0101. So 4 bits it has become. So 5 and this is 7 in your table, so this is 57 in hexadecimal. Understood?
Yes.
Same way, this is one more number 10111011. Right? So we divide from the last digits, that is end. 1011 is 4 and this is 1011 is 4. In 4 bits I have divided, so 1011 is B and B. So B is your answer from your table, right?
Yes.
So this is how you convert hexadecimal to binary and binary to hexadecimal. Any problems?
No.
And also I have also told you how to convert a hexadecimal to octal or octal to hexadecimal.
Yes.
Yes?
Ma'am, can you show that 175 number conversion?
Which number?
1756 by 16.
1070.
1756 by 16.
That's
This number just converted. Write the one equivalent of 1 is 0001, 7 is 0111, 5 is 0101, 6 is 0110. Write it. Converted. What's the problem? 1 you know, na? It is from the table. It is 0001, right? Yes.
No, I'm writing. So I'm writing it. That's why I told you to keep that screen on. Just
7
for a
is
minute.
0111. 5 is 0101. 6 is 0110. Right? Again, I'm
Yes,
telling
ma'am.
you,
I'm done.
leading 0 will not be counted. Just count it from the first one which is there. That's your answer.
Yes, ma'am.
Anything else?
No, ma'am.
Understood both the things? Binary, decimal to binary, then octal, then hexadecimal. Understood?
Yes.
Everybody.
Yes, ma'am.
Yes, ma'am.
So now, suppose now have we converted any decimal number to octal or any decimal number to hexadecimal? Have we converted?
No.
Not yet.
Right. So that also we have to do. So that is, how do you convert a decimal to octal? A decimal number is given, suppose 127 base 10 is your decimal number. You have to convert it to octal. So you always remember, whenever you are converting a decimal to binary, decimal to octal, decimal to hexadecimal, it will be divided by the base. You understand?
Okay.
What is the
So
method?
just divided by base.
Divide by base, and the
But-
remainder will be your answer. In binary, remainder will be always 0 and 1. In octal, remainder will be 0 to 7. In hexadecimal, remainder will be 0 to 15.
But this only implies if we are converting it from decimal
Decimal
to anything.
to whatever
To
form.
octal.
Decimal to
Okay.
whatever form you are converting, whether binary, octal, or hexadecimal, it will be divided by the base. So
Base.
binary's base is 2, you will divide by 2. By octal's base is 8, you will divide by 8. Hexadecimal's base is 16, you will divide by 16. And the remainder is the answer. Right?
Okay.
Okay, ma'am.
So
Okay,
0,
ma'am.
1 will come in binary. 2, you divide by 2. 0 to 7 remainder will come in octal if you divide it by 8. 0 to 15 the remainder will come if you divide it by 16. Understood? 0 to 7 any remainder can come in octal.
Yes, ma'am.
Like in binary, 0 and 1 can come. So here 0 to 7 can come, any number, remainder. In hexadecimal, 0 to 15 can come, any number, remainder. Understood?
Yes, ma'am.
So decimal number 127, we divide by the base, that is octal's base is 8. So 8 ones are 8, remainder, how much remainder is? 47 will be there, right? 4 and 7. So 8 5s are 40. Because 8 6 is 48, so we can put that. 8 5 is 40, remainder is how much?
7.
7. Then 8 1s are 8, what is the remainder? 15
7.
minus 8 is 7. Right? So what is the answer? Again from down to above, 177. Yes or no?
Yes, ma'am.
Yes.
Yes, ma'am.
Any problems? I have taken a small number, you can take a bigger number also. But I have taken a small number to explain. Right. Now if you want to convert an octal number to decimal, अब वापस convert करना है, मतलब reverse. So same number I have taken 177 base 8 and you have to convert it into decimal. Now the same procedure which we had done in binary to decimal. What we have done in binary to decimal, you will count the number of digits and multiply, add and multiply the digits to the power 1 less power. Remember?
Yes, ma'am. Yes, ma'am.
So same way here also we'll count the number of digits and 1 power less we will take, and that is 1. First number is 1 into 8 to the power here it will be, not 2 to the power, because that was
it's octal.
binary.
That
this
was
is octal.
binary. Yes.
So 1 into 8 to the power 2, because 3 digits are there, to 1 power less is 2, plus 7 into 8 to the power 1 plus 7 into 8 to the power 0. Right? So anything to the power 0 is 1, so this will be 7 into 1 is 7. 7 into 8 is 56, and 8 to the power 2 is 64. 8 8 is 64, right?
Okay, ma'am.
And you add it, what is the answer coming?
127.
So your answer is confirmed that your answer is right, right? You had verified. Yes?
Yes.
Ma'am.
So this is how you do it. For hexadecimal also the same procedure will be followed. Now suppose you have a number called 158 base 10.
So we'll divide it by 16.
Divided by 16, remainder will be 0 to 15 any number. Right? So
Yes,
16
ma'am.
nines are, if you do it, 16 nines are is 144. So 158 minus 144 will come out to be 14. So your answer is 9 and 14. 14 in hexadecimal, you will not write 14 directly. You know that it is alphabet. Do you understand?
Yes.
In 0 to 9 are the numbers which are there. 0 to 9, so you can write the normal numbers, but 14 will be written as E. Right? Who is speaking? Please mute your mic.
Aman muted.
Mute your mic.
Right? Can you understand?
How did it come 9 E? I thought it should be 1 E.
1 E? No, 14. 1 4 you have to take the full number. Why one separate and 4 separate?
Okay.
The remainder is 14, na?
Yes, it is
Not
14.
4
So
or
we
1
denote it by E.
separately. What?
And how does the 9? Okay, we know that 14 is denoted by E. So we have written it E.
Yeah, and
But,
9 is here. 9 is
okay.
separate, 14 is separate, na?
Yes. Sorry.
So 9 and E. 1 and 4 we cannot separate. That are not separate numbers. 14 is combined 14.
Okay.
So 16 nines is 144. So 144 when we subtract the remainder is 14. Yes or no?
Yes.
Yes, ma'am.
So 14 will be 14 is not written 14 in 1 4 or 14 in hexadecimal. We write E, the alphabet. After 9 all are alphabets. So up to 9, so 9 so we'll write 9 only. But 14 is written the alphabet. If 10 is the remainder, then also alphabet. 12 is the remainder, then also alphabet. 13 is the remainder, then also alphabet. So 10, 12, 11, 12, 13, 14, 15, if the remainder comes, it will be alphabet. Understood?
Yes.
Right. Then when we say, suppose hexadecimal to decimal, the same procedure which we did in Octal, 9E is the hexadecimal number. Right? Suppose 9E is the hexadecimal number, the same number which we are taking, right? So now there are two digits right here. Yes. So 9 into 16 to the power 1 plus E in actually E is 14 or not?
14.
Yes.
E is 14, so 14 into 16 to the power 0 we will say.
Yes, ma'am.
Right. So 9 into 16 is 144 plus 14 into 16 to the power 0 is 1. So 14 into 1 is 14. What is the answer?
158.
158. The same answer you have derived. Understood?
Yes, ma'am.
How to convert this both? Octal also, hexadecimal also. This is from decimal to octal, decimal to hexadecimal, or hexadecimal to decimal, or octal to decimal. This is what is there. So basically the formula for that is actually, sorry, this is decimal to binary, octal and hexadecimal. If you want to convert, it is divide by the base and remainder is the answer. Do you understand?
Yeah.
Right? This is your procedure for decimal. Then if you want to convert binary, octal or hexadecimal to decimal, then multiply by the power of the base, which we are doing here.
Yes, ma'am.
Right? This is the procedure. But for decimal conversions only, decimal to binary, decimal to octal, decimal to hexadecimal, or binary to decimal, octal to decimal, or hexadecimal to decimal. These are the two procedures. Right?
Yes.
Any doubt? Any doubts in this?
No, ma'am.
So this is your whole number system actually, conversion. This is the whole conversion you have done. From each decimal to binary, binary to decimal, or binary to hexadecimal, decimal to hexadecimal, whatever. All the conversions you have seen, right?
Yes, ma'am.
Yes.
Now, suppose you are given a decimal number, which the one of the persons have talked about. Suppose this kind of a number is given. This is a decimal number, but there is a decimal point also, right? Then how to convert this number, right? So first you see the integer part. What is the integer part? 127, yes?
127.
Yes, sir.
And the decimal part is 0.75, yes?
Yes.
So first you take 127, the integer part, and divide it by 2, like you were doing for other numbers, right? We were doing
Okay.
for decimal to binary, we were dividing it by 2, na?
Yes.
Yes,
So
ma'am.
same way, what we will do is we will take the integer part and divide it by 2, and keep on writing the remainder. That is 2 6 are 12, 2 3 are 6, remainder 1, 2 3 are 6, 2 1 are 2, remainder 1, 2 1 are 2, 1 are 2, 2 5 are 10, remainder 1, 2 7 are 14, remainder 1, 2 3 are 6, remainder 1, 2 1 are 2, remainder 1, right?
Yes.
So the
Yes,
answer
ma'am.
is 7 times 1, right? The integer part, right?
Yes.
Now, what about 0.75, the fractional part or the decimal part? The 0.75 I have written here, 0.75. 0.75 is not to be divided by 2. It has to be multiplied by 2. And you have to bring the this 0.75 to 0. You have to keep on multiplying this decimal part with 2 until you get in the integer part in numbers and in the decimal part 0. You understand
Okay.
what I'm saying?
Yes. So after point, you have to nullify it till 0.
Yeah, you have to nullify it till 0, and the carry forward numbers should be taken here. In the integer part, whatever number is coming, whether it is coming 1 or whether it is coming 0 here, you have to put it here. Right, I'll just tell you.
Ma'am, can you show this one time?
That's what I'm doing. 0.75 multiplied by 2. So 2 5s are 10, 1, 2 7s are 14. Plus 1 is 15, right? Yes or
Yes.
no?
Yes,
Yes,
ma'am.
yes,
5
ma'am.
is
Yes,
there and the 1 will go here, carry.
yes, ma'am.
Right, so
Yes.
two zeros are 0, so 1 will be there. So here we have not put it here, 1 we have put it ahead here. The integer part we have to keep it. The integer part we need. So that is 1. Do you understand?
Yes.
Yes, ma'am.
Now also it is not nullified, the number is not nullified, so it is 0.50 now. Again multiply it by 2, 2 zeros are 0, 2 5s are 10. 10 means the carry forward is 1 here,
Yes.
right?
Yes.
Into the integer part, so 2 zeros are 0, 1 I have put it here, right? Now it is nullified.
Yes.
Yes.
So my answer for the decimal part has to be read from above to down, not from down to above like we were doing for the integer part. For this
Okay.
part you have to do it
Up to down.
up to down. So that means your 7 digits is there, .11.
Okay.
Understood?
Yes, ma'am.
So your
Okay, ma'am.
127 base 10 is 7 digits 1, and 0.75 is 0.11. So this is your answer.
Yes.
This is how you convert. Can you understand?
So does this procedure apply to any base we convert it from decimal to any?
Yeah, this procedure decimal to binary. Generally, they will ask you only for decimal to binary, but this procedure can also be worked for in octal also or hexadecimal also. See,
Okay.
if suppose this is a octal number, I'm just giving you an example. This is an octal number. You have
Yes.
to convert it into binary. So 1 ka equivalent you will write 0012. 2's equivalent is 0, 0's 10, and 7's equivalent is 111. Right? Dot point you will put it here. 7 is 111 and 5 is 101. No, that's all converted.
Okay.
Equivalent numbers only you have to write now.
Yes.
In octal and hexadecimal, so it is easy.
Because we have to just take the values from table.
Yeah.
Okay.
In decimal, generally you are not asked for octal or hexadecimal, the decimal part. You are always asked for the decimal to binary conversion in a
Okay.
fractional part. Right? In the assignment also maybe such kind of a question may be there. Decimal part conversion. right? One more thing you should remember, sometimes what happens is that this fractional part may not completely go up to 0.
Okay.
Right? Sometimes what happens is the same 0.40 or some numbers again repeat.
Okay.
Again the same number comes. So that is known as repeating decimal. So you don't keep on dividing, because it will never, the fractional part will never get divided. So keep it up to 3 digit numbers.
So just one
3
more.
or 4 digits. Huh?
Okay.
So those are, you can put a bar above that this is a repeating decimal. Because again and again the same number will come. You keep on multiplying by 2, the same number will come again. It will not go on to 0. So there are repeating decimals also, na?
Yes.
So there may be such kind of a situation. Now suppose if you have, suppose here remainder would have been 0.625. The fractional part have been 0.625. Then not 75, it had been 625. Then multiply by 2, 2 5s are 10. 1 is carry forward, then 2 2s are 4 plus 1 is 5, 2 6 are 12, 12 and the integer part 1 is here, right? So now your fractional has become 0.250. Now again multiply by 2, 2 zeros are 0, 2 5s are 10, carry forward 1, 2 2s are 4 and 1 5, and no carry forward is here. So I have forwarded 0. Right, again I'll multiply by 2, 2 zeros are 0, 2 zeros are 2 5s are 10, and carry forward is 1, so I put it 1 here. And now your whole is converted into zeros. So your answer will be 101, 0.101.
So just assume that if we have any integer that can go even further than this, we can just stop at this 3 digits.
Yeah, it is going on, so you cannot keep on multiplying, and again the same digit will come back.
Okay.
So it will not come out to be zeros. But generally you will not be given repeating decimals. But if you are given a question of repeating decimals, then just keep it up to 3 digits. That's all. Right? Any doubts in that?
No.
Right. Now, if you have a number, the same number I have taken here, some other number I have taken. So and we have to convert it into decimal now. We have converted decimal to binary, right? This is decimal to binary. Now, binary to decimal, how do you convert? The same procedure which we were doing, multiplying by the power of the base. So you take the integer part first. Integer part is 1, 2, 3, 4, 5, 6 digits, right?
Yes, ma'am. Yes, ma'am.
Right, 6 digits are there in the integer part. So I'll take 1 power less, 1 into 2 to the power 5, 0 into 2 to the power 4, 1 into 2 to the power 3, 1 into 2 to the power 2, 1 into 2 to the power 1, and 0 into 2 to the power 0. These digits I have covered, right?
Yes.
Yes, ma'am.
Right. Now the fractional part, what happens to the fractional part? Fractional part has power, negative power.
Since it's in the negative on the rule line.
Yeah. So this has negative power. So plus, the first number is 1. Now here the power will keep on increasing. -1, -2, -3. Not like here. 5, 4, 3, 2, 1, 0. Not like here. It will keep on increasing. Do you understand?
Okay.
So here 1 into 2 to the power -1, 0 into 2 to the power -2, 1 into 2 to the power -3. Right?
Yes.
The fractional part.
Yes, ma'am.
So what is negative power? Whenever we are talking about 2 to the power -1, 2 to the power -2, negative power is reciprocal. If you want to create a positive power, what will I do? 1 by. I have to make it 1 by. Do you understand? I cannot calculate negative power, can I?
No.
So how will I make it a positive power? You have to reciprocal it upon 1. That is 1 upon 2 to the power 1. 0 upon 2 to the power 2, 0 into 2 to the power 2, so that will come out to be 0 only, so I have not taken that. Then 1 into 2 to the power 3 I have taken, 1 upon
2 by raised to 3.
Understood?
Yes.
Negative power is also always reciprocal to make it a positive. So these I have calculated, so this is 32, 8, 4, 2, this added it to 46, right? The integer part. Understood?
Yes.
Then 1 upon 2 to the power 1 plus 1 upon 2 to the power 3. That comes out to be, if you take the reciprocal and add it, and it will come out to be 5 by 8. The LCM, if you take the LCM, what will it be? 8?
Yes.
2 to the power 3 is 8 and this is 2. So LCM is 8 now.
Yes.
So here 8 will be divided by 2 will be 4. 4 plus 1 is?
5.
5. 5 by 8 it will come generally, right?
Yes.
5 by 8 that has come. Just divide 5 by 8. What will be the division?
0.625.
That's the answer. So 46 plus 0.625 is 46.625.
Okay. So we just made those bases like common 8. We did the LCM. Yes. So,
Yeah, we took the LCM.
okay.
If you want, you can also 1 by 2 is 0.5, I think.
Yes.
Right, and 1 by 8 you can divide and you will get, I don't remember.
0.125.
So you can add these also, like this also you can do if you don't want to take the LCM. 0.5 and 125, right? What?
Ma'am.
Yes, ma'am. 0.5 and 0.125.
So 0.5, so 5 will be below 0.125. Below 1, 5 will be there. Remember that. Do you know that? Do everybody knows that? How to add decimal numbers?
Yes, ma'am.
Yes. Yes.
Yes, ma'am.
Because it will be 0.125, that is 1 by 8, and 0.5. 0.5 like this. Under 1 it will come. And if we talk about ahead are zeros only.
Yes.
So it will be 6 to 5.
0.625.
Answer will be, you add both the ones, the answer will be 6 to 5, na?
Yes.
This is how you add it. So that this can also be done, no problems. This way also you can do it. Right? If you don't want to take the LCM.
Ma'am, can you re-explain the LCM part?
What do I explain means?
Can you
LCM
explain
part.
him the LCM? How do we take the
This is 2
LCM?
to the power 1 is 2. Yes? And 2 to the power 3 is 8.
8.
So 8 and 2, the LCM of 2 and 8 will come what?
And 8.
8. So 8 is your LCM. Now 8 is divided by 2. What will be the answer? Question 4.
4. Yes, ma'am.
4. So 4 into 1 is 4 here.
Yes, ma'am.
Plus 8 divided by 8 is 1.
Yes, ma'am.
And the above 1 will be 1 into 1 is 1 here. Right?
Yes,
so
ma'am.
4 plus 1 is how much?
5.
5. This is how you have calculated the LCM. But if you don't want to calculate the LCM or you have forgotten how to calculate the LCM, the other thing is divide 1 by 2, it is 0.5, plus divide 1 by 8, it is 0.125.
125.
Do you understand? Add both of them, 0.5 and 0.125, it is 0.625.
625.
Yes.
If people have forgotten how to take the LCM, just forget it. Divide both the things separately, and the decimal part, add it, and this is your answer. So now your integer part is 46, decimal part is 0.65, so it is 46.0625.
Yes.
Understood?
Okay. Yes.
Yes, ma'am.
Yes.
Yes, ma'am.
Any doubts? Anybody is having any doubt in this?
No.
This is your whole number system. This was your number system. This is what is all your number system. And in your assignments also, if a question is asked about
Yes.
number system, these will be there. Any doubts anybody is having?
No.
No, ma'am. No, ma'am.
Everybody is clear with this?
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now
Yes,
you
ma'am.
can also try it at your home, try it out how to calculate it, right? But they have also number systems, they have given it. So a computer processing is performed by transistors basically, so which are switches with only two possible states, on and off. So basically, you know, in your chip, your microprocessor chip, transistors are there, right?
Yes.
Yes, ma'am.
So transistors are generally switches, and switches always have on and off possible states, right?
Yes.
Yes, ma'am.
So all computer data is converted to a series of binary numbers, that is 1 and 0. For example, you see a sentence as a collection of letters, but the computer sees each letter as a collection of ones and zeros. You understand? Suppose
Yes.
I write a sentence, A will be some binary digit, B will be some binary digit, whatever I am writing. So every letter will be a collection of binary numbers according to computer, because it converts everything into binary, right? So if a transistor is assigned a value of 1, it is on, and if it has value 0, it is
It
off.
is off.
I have already told you that 1 is on, 0 is off. So computer transistors can be switched on and off millions of times each second. Your transistors are switched on and off millions of seconds. So that is what binary number system generally is. So this we have already seen, your convert data into numbers. We have already seen that. I'm not going for that. They have just given you humans how we in decimal, decis, 10 and all that. We have already talked about. We have also talked about bit and byte also, right?
Yes.
So we know that the smallest
Yes.
unit is bit, and a value 1 or 0 will be 1 bit. You understand? If we are talking about one value, 0 or 1, whatever value it is, on or off, it will be 1 bit.
1.
So if we group the values, it will become a byte. If we group the values, group the bits, what will it become? It will become a byte or nibble or kilobyte or megabyte, right?
So if there were 8 strings of numbers 010101, that would be a byte, and
Yes.
yes, for a kilobyte that would be 1024 zeros.
Generally, when we talk about the memory, so the fastest memory in your computer are registers. Do you know that? Do anybody knows what are registers?
Yes.
They are the fastest memory in your
Yes, ma'am.
computer, and they are part of your CPU.
It
CPU
is also
memory.
cache memory.
Cache memory is not the fastest. Cache memory is second to the registers.
Okay, ma'am.
So after cache memory, after registers are the cache memory. Registers are the fastest memory, and they are the CPU memory. And CPU is the fastest, so its memory will also be the fastest, na?
Yes, ma'am.
Right. So CPU, if your CPU or your operating system is of 64-bit, so your one register will be of 64-bit. Do you understand?
Yes.
64-bit processor, if it is 64-bit processor, so your one register in your CPU will be of 64-bit. And if it is a 32-bit processor, then one register will be of 32-bit. So nowadays you are having 64-bit processors.
Ma'am, will you please explain the register once again?
Registers are the fastest memory, and they are the CPU memory. Your CPU calculates, suppose ALU calculates some numbers and keeps the answer somewhere, so that is the CPU memory it keeps in. It keeps inside it in registers.
Okay.
And the register data is then transferred to the RAM or wherever you require it.
Is it the integral part of CPU?
Yes, it's a part of CPU's memory, registers. They are the fastest memory.
Okay, okay. Is it a CU or ALU? Is it the part?
No, it is not CU or ALU. That is, CPU is divided into two parts, ALU and control unit, but
Yes.
arithmetic logic unit and control unit. That is
Yes.
part of CPU,
Okay.
divided into two parts, right? But that
Okay.
is, CPU has inbuilt memory, that is registers. where suppose control unit gets the data from some data that it needs to be calculated. Control unit is the one which is handling everything for the CPU, right? Taking data from the devices and giving you output to the devices. So CPU is the control unit is the one which is doing that. So suppose you have taken two numbers. So control unit sees what instruction is given that these two numbers has to be added. So what the control unit does is it gives to transfer it to the ALU that calculate it and put it in the registers. The answer has to be, the numbers have to be put it in the registers and the answer also have to be put in the registers, because some memory the data has to be put now so that the ALU can calculate.
Okay, means
So that memory
ALU,
registers.
ma'am, ALU, CU, and the register all are three different of the items.
See, when we talk about registers, that is part of memory. That is not part that we don't say that CPU has three parts: registers, control unit, and ALU.
Okay.
It is
Then I got
only control unit and ALU which are part of CPU, but it also contains registers also to keep something inside, to calculate and keep the temporary result inside. That is your registers, the fastest memory.
Okay. Thank you, ma'am.
Right. So this is how we represent bits and byte. We have already taken care of, and 1 byte. With 1 byte, the computer can represent one of the 256 different symbols or characters. If you talk about 1 byte, it is 8 bits, right?
Yes.
1 byte is 8
Yes.
bits. How much is 2 to the power 8? How much is 2 to the power 8?
256.
256. So that means your computer, if it is a 8-bit 1 byte or 8-bit representation, so it will be 256 characters it can represent. Do you understand?
Yes, ma'am.
Yes, ma'am.
So that is what. Now suppose your register is of 8 bits, so you can represent in the registers 256 characters you can keep. That what it means. And if you have 64 bit, see how much large now you can keep the character set. Do you understand?
Yes.
Yes.
So that is there. We don't go for that. Then you have, suppose earlier what happened was the keyboards for different companies in the initial times, every company used to make their own keyboard, right? So what happened was, suppose I cannot put a HP computers keyboard in IBM computers system, because HP or whatever company, I'm just giving you an example. So what happened was the keyboard had their own codes. There was no standard code. They had their own code. For A, they will have their own binary code. For B, they will have their own binary code. So you cannot take the same keyboard to all the companies' desktop. So what happened was, nobody could share their keyboards or nobody could have plug and play features. Do you understand what I'm telling you?
So no compatibility was available.
Yeah, compatibility was not there. So what happened later on, they decided that there should be some compatibility, that plug and play should be there, and each alphabet or symbols or special characters or numbers, whatever are there, should have the same code for each alphabet or digits or whatever. So they decided to make to represent human readable format things. They made a code known as Ascii Code, American Standard Code for Information Interchange. Right? That was the standard code each and every keyboard used to follow. Can you understand? So now if you take any keyboard and press A, the same, whatever the code, Ascii code has the standard, that code will only be taken. And the compatibility issue was solved. So earlier the Ascii code was 7-bit, later on it was made as an 8-bit code, that is 1 byte of data. Ascii is used in nearly all personal computers. Right now all the keyboards are Ascii code keyboards, right? And nowadays also, earlier also one more code was used, that was Ascii. This also has a full form. I don't remember the full form. You can see in your books. That is also an 8-bit code, and but is used primarily in older mainframe systems. The old systems were using this Ascii code also, but nowadays you are generally using Ascii, and also one more code you are nowadays using, that is known as Unicode. Text code set. Each character consists of 16-bit, 2 bytes of data. So why 16-bit from 8-bit it has increased to 16-bit? Because nowadays you have different language formats also added in your keyboard now. Yes, you could write in different languages also.
Yes.
That's why
Yes,
Unicode
ma'am.
has also been created nowadays. So you have different language formats also. Any problems in this?
No, ma'am.
Right. So if you want to see, you can go to the internet, see the Ascii table. Right? See the Ascii table. A, I think capital A is from 65, decimal number 65 to A 65, 66, 67 up to Z. You can take it. I don't know. I don't remember up to what digit it is. 65. Just keep on increasing. So A to Z from 65 it starts. Decimal number, and that can be converted into binary. 65 can be converted into binary. It will understand it is A, and small letter A to Z is from 92 or 91. I don't remember. And special characters also, some special characters also have 0 to 9 numbers also have. So decimal numbers are given in the table. Do you understand what I am talking?
It shows from 65 to 90 alphabets, and 91 to further on are those symbols or characters, you can say.
So there are different digits which are given. So that is what is taken. That is what is represented in binary, that decimal number. Do you understand? And it will give you in human readable form that it is A, B, C, D, whatever. Right?
Yes.
That is what Ascii code is. And now you have Unicode also. So this, see here, if it is 0 to 5, they have taken some numbers, right? That A, this must be 65, I think, in binary. Right? B will be 66, 67, like that. Do you understand the code? The digits in decimal what is given will be converted into binary. Can you understand that?
Yes.
Yeah, that is what you can see the table and see the decimal numbers which are 0 to 9, what from where to where it starts and ends, and ABCD from where it starts and ends. From the table you can see that. Right now,
I
yes.
have one question, ma'am.
Yeah.
How a computer system recognizes what system is running? Is it Unicode or ASCII or other?
Generally, your keyboard will always be having the Ascii code. It will always be Ascii code.
Okay.
But nowadays, multi-language keyboards are also there, which are also using Unicode.
Keyboard, you want to say that physical keyboard on the system?
Yeah, physical keyboard. What
Okay.
keyboard I am talking about? Physical only.
Okay. And that signal goes, that is detected as ASCII or Unicode, whatever.
It is, see, the normal keyboards are generally Ascii.
Okay.
Your normal keyboards are generally Ascii keyboards. Do you understand?
Okay,
The
ma'am.
alphabet, special symbols, 0 to 1 numbers, these are only your keyboard, na?
Yes, ma'am.
There is no language facility right now in our keyboards, right?
Yes.
But there are
ma'am.
keyboards which are for special language facilities also. Yes or no?
Okay, ma'am.
For those keyboards, Unicode is also being used now.
Okay.
Like for example, we currently use the QWERTY type keyboard. We have this QWERTY, which is this mechanical keyboard or any keyboard. but there are multiple different keyboards as well which don't follow this type of set. They may be running Unicode maybe, or even ASCII as well.
They can run both also.
Yeah.
Okay.
Right. So what we'll do is we'll talk about this processing part. We have already talked about control unit, arithmetic unit, logic unit. We have talked about earlier also, but we'll still take it. We'll explain it more in the next tomorrow's class. And then we'll talk about the memory part also. Right. So we'll see that.
Yes, ma'am.
So these are your first two units generally. If we talk about that, first two unit is there. Then unit 3 is, I'm just seeing what is inside it. Memory system, that will be covering your memory system also, the RAM, ROM, and the fastest memory and all that, right?
Yes,
So that will be covering that, types of ROMs and your hard disk and pen drive, secondary memories also. So we'll do that tomorrow. And the fourth unit is input-output devices. So see, these input-output devices, I'll discuss about ports and all that. We'll discuss about, but these things you can read yourself also. Like the input devices are keyboard, right? So you can read yourself also. Keyboard has QWERTY keys, 101 to 104 keyboards are also there. So alphanumeric, punctuation mark, special keys are there. Mouse is there. That is another pointing device. That is another input device, right? So types of you have earlier had mechanical mouse, then optical mouse have come. Now cordless mouse has come. USB, right? USB mouse is your optical, and now cordless have also come, right? Then digitizing tablet is there, right, where you can write and it will be for CAD/CAM, for computer-aided design and all. Whatever you write it on here, it will be displayed on your monitor, or draw it here on the tablet, that kind of a thing. Trackball is for games generally, right? Or in your laptop also you have trackball, right? In laptop, the mouse pointer which is there is your trackball. You understand?
Okay.
But separate trackballs are also coming. Mechanicals were also there, but now touch trackballs are there. And joystick is your gaming device. Some gaming devices still uses joystick to play games. So these devices have been given their definition and all that. Then you also have light pen. Light pen is also an input device. Yes or no?
It's usually used right now for teaching online on those boards.
Online teaching, or even in if somebody has made a driving license and all, you sign with a light pen on a notepad, and it is displayed on the like a graphic tablet.
Yes.
That also has a light pen where your signatures are put inside that computer. So that is there. Touch screens have come now, right? Touch screens, ATM machines also have touch screens, so that is there. Then digital camera is also there. So digital camera, you can have your pictures clicked and you can put it in your system. So digital cameras are there. Then scanners are there. Scanners is also an input device where you take a handwritten or document or something and put it inside your computer, scan it and put it inside your computer as a soft copy, right?
Yes, ma'am.
Right. Then there is another input device called optical mark reader, OMR. Right? Some of you must have given some entrance exam or something.
Yes.
It's a OMR sheet.
Yeah. Read that OMR sheet. Your outputs are inside your system. To match that, your answers from the OMR sheet, and OMR machine is there. It takes your answers from the dotted marks answers from there and matches it with the computer's answers. That is optical mark reader, OMR, right? So this is a machine. Then magnetic ink character recognition, MICR, is another machine. This machine is generally used by the banks. So banks have a special. This has a special ink which can only be read by this machine. The checks have special numbers written in special ink at the bottom, and those numbers, when put it inside this machine MICR reader, it reads that magnetic ink character recognition and recognizes that this is a valid check of this bank, of this branch, and all that. Every information is written 000. Some numbers are given in special ink, and that is read by this machine for checking the valid checks and all. Right? So that this is magnetic ink character recognition. So that is used by banks generally. Right? Then you also have barcode reader. This you must all have seen also.
Yes.
In many shops
Yes,
and all
in
that.
many shops.
So all the products have at the back of them have barcode, and in that barcode the lines, black and white lines. In this, the information about the product is given, the price, the code, the name of the product, everything is written in. So the barcode reader, this handheld device, reads this barcode and gives you the bill and puts the price on the system, right? So this is another input device. Then you have magnetic stripe reader also, right? That is your ATM card, which has magnetic stripe, and which where your all the card information is inside that stripe. Have you you all have the ATM cards now of banks and all? At the back there is a black strip, that is the magnetic stripe, and the ATM machine has that magnetic stripe to read that, or the what POS machines also have that magnetic stripe reading. So it reads the information that it has money, and it debits or credits the money accordingly, right?
Yes, ma'am.
Right. So that is also there. So these are the input devices. Then output devices, you have monitors. So you have different types of monitors like cathode ray tube. Earlier cathode ray tube were used in TVs also and in monitors also, CRT monitors. Right?
Yes.
So this kind of a monitor was there. There was a cathode ray tube where electronic guns, through that gun, the light was put on the screen, and the phosphorus on the screen makes the image on the screen. That was LCD monitors. Then came LCD, liquid crystal display, right? So they were first and foremost flat thin film transistors, or flat screen monitors. LCD monitors were flat screen, and they were sharper and more brighter than the CRT monitors. And also they used to take less heat and energy than CRT monitors. CRT monitors used to make lot of heat also.
And
right?
I think LCD monitors don't use lens. They required lens, bigger lenses in CRT.
Lenses? What lenses? No, lenses, they uses thin film transistors actually.
Yes.
At that time, they uses thin film. They didn't use any tube or anything like that, like CRT. So they were flatbed. Then your LED monitors have also come nowadays. Yes, light emitting diodes. So they use the same LCD screen, but the behind technology is not the transistors. The behind technology is the LEDs. Do you understand?
Yes,
So
ma'am.
light emitting diodes, and they are more sharper than LCDs, and the thin film transistor, they are more sharper than that, and they have become more lightweight now, and they also don't heat up too much. LCDs also a little bit heat up, LEDs don't heat up too much, and they take less power consumption, and they also don't have flicker screen problem. Flickering problem is also not there in LEDs. Right? Then you also have projection displays. Projection displays is your projector, right?
Yes.
Overhead projectors. So that is also what you say output device for presentation and classroom lectures and conferences. You used to have that. So there are different kinds of things: monochrome, grayscale, color monitors also. So projections also can have that, the same thing. So you should know what is resolution in how many pixels an image can put is your resolution. Pixel is the smallest element of image. Right. So analog and digital monitors are also there. They are given you. That is one thing. Then printer is another technology. Output unit which is there. So printer, you have two kinds of printers, impact and non-impact printers. Do you understand what are impact and non-impact printers?
No.
Impact means which touch the ribbon and print, like a typewriter.
Yes,
Right?
ma'am.
In the typewriter, what happens was the alphabet which was on the a pin. The alphabet is when we press a alphabet, the pin used to touch the ribbon, and after the ribbon is the paper, and the image of that alphabet was printed on the paper. So those printers are kind of a typewriter, are known as impact printers, which touch the ribbon and print. Do you understand? And the second are the non-impact printers, and non-impact printers are nowadays we are using non-impact printers only. So non-impact printers which do not touch the ribbon and print. They have different technology. Like you have inkjet printer, laser printers. They don't have any ribbon or anything, which they will touch and make an image. The inkjet printers have a nozzle which sprays the ink and makes the image on the paper. And laser printer have laser technology through the heat, the powdered cartridge is there, powdered form ink is there in the cartridge, and through laser heating the image is printed on the paper. You understand?
Yes.
So there are two kinds of printers, impact printers and non-impact printers. So the printers also have the speeding basis of speed. They are classified like character printer, daisy wheel printers according to speed. These character printers are generally your impact printers. Dot matrix, daisy wheel, these are all impact printers which touch the ribbon and print. Right, so you can read that also, and the advantages and disadvantages also you can read. Then line printers, page printers are also there, which are impact. And non-impact printers, you have inkjet printer, you can read the quality of that, disadvantage of that. You have laser printer, you can read that. And another output device is plotter. Do you know about, anybody knows about plotter?
It's a bigger one for printing maps and
Yes, for printing maps, for banners, for
even
magazines
those
and all
constructions, blue charts and all.
Yeah, so they are graph plotters also. So they are bigger printers. So they have different kinds of plotter pens, colored pens through which they can print different color formats. So that is a good quality printer, but they are used for special applications only, or bigger design applications only. So you have drum plotter also and flatbed plotter also. There are two kinds of plotters. Then you also have output device like speakers and microphones. Speaker which gives you sound from the system, right? And microphone is also there, right? But microphone I think should be inside your input device, because your sound goes inside the system through the microphone. So I think it should be not an output device. Output device will be speaker. Microphone will be input.
And ma'am, that is tablet. It is there. It should be input and output both. Now that monitor.
It should be, but generally it is taken as an output device only. The monitor is generally taken as an output device.
Output.
Yeah. It shows you the input and input also what you are typing the input, and the output also it shows, but it is generally taken as an output device. Yes?
Okay.
Right? So this chapter you can read yourself. That is your 4th unit in block 1. Input output devices. Yes? If you have any doubts or if any problem is there, we can discuss it. No problems. Is there any problem in reading this chapter?
No, ma'am.
Right?
No, ma'am.
Then we have already discussed this also, like laptop, tablet, PC. So, but we'll see this once we will. There different kinds of softwares and all are there in this. So we'll see that. Just make a thorough review of that tomorrow's class. But first and foremost, we have to do the memory system tomorrow, right? That is our main motive. So I'm stop presenting. Everybody has written their enrollment number and name in the chat box.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Ma'am, I'm just sending it.
Just write in the chat box your attendance, please.
Yes.
Yes, ma'am. I'm sending.
And we'll meet tomorrow. See, whoever have queries and all that, like they are not able to log into the LMS or they are not having any subject inside their LMS, whatever. I have conveyed it to the IGNOU authorities and they are taking it with the IGNOU, how can they solve your problem, right? So
Okay,
don't
ma'am.
worry about that. What is, yes.
Ma'am, can we get like link of that recording?
See, that is not in my hand. I cannot give you. That can be given by the IGNOU authorities only. So they will upload it once on the LMS portal also of yours and on the YouTube also. Just wait for some time. Don't
Ma'am,
worry.
can we get notes of the classes?
Yeah, I've told you that. I will add it myself into the WhatsApp group. I will give you the notes.
Thank you, ma'am.
Okay, ma'am.
Anything else?
No, ma'am.